Hello everyone, let me walk you through what the lab's going to be for this week. So let's start off with this example. I have this block that we are going to release from rest on this frictionless ice. It's going to slide down and then we're going to record what the final velocity is at the very bottom. Now we're going to do this for a bunch of different heights, 2.5 meters, 3.5 meters, and so on. And then here's a table of data of all the final velocities that were recorded when it was released at these different heights. Now, how are we going to plot this? What do we expect the slope to be? What do we expect the y-intercept to be? In order to answer that question, we're going to do what we always do, and that is start with a physics equation. In this case, we're going to use conservation of energy. So here is our big term for conservation of energy. Thankfully, a lot of these are going to be zero. First of all, we released the block from rest, so our initial velocity is zero, so that whole term is gone. There's no springs in this system, so this term is going to be zero, and this final spring potential energy is also going to be zero. And also, right before it hits the ground, the height is going to be zero, and so that term is zero. So all we're left with is these two terms here, gravitational potential energy initial and final kinetic energy. So here's the equation we end up with. Now, if you notice, there's mass m on both sides of the equation, and so when we divide m to both sides, it goes away. So m just kind of goes away from both sides. Now, to simplify this, remember, we're trying to get to that y equals mx plus b form. I'm going to multiply 2 to both sides. And then I'm going to flip this. I'm going to have final velocity squared equals 2gh initial. So from here, I added that plus 0 because we want to get it in this form of the y equals mx plus b. So what do you think? What should we plot in the vertical axis or horizontal axis? And what is the slope and intercept going to be? So let me make that a little bit bigger. So if you see that final velocity squared is in the y position, so we're going to plot final velocity squared data on the vertical axis. Height initial is in the x position, so we're going to plot height initial on the x-axis. And 2 times g is in the position of the slope, and 0 again is in the position of the y-intercept. So by plotting final velocity squared, again, not just final velocity squared on the y-axis, height initial on the x, we expect the slope to be 2g and our y-intercept to be 0. Now, we don't have final velocity data. We don't have final velocity squared data, do we? So what we can do is we can take our final velocity data and then just square it in our calculator. So we took 6.32 and we squared it to get 40, 8.19 and squared it to get 67 and so on. So that's what we're going to be doing in our lab as well, squaring that velocity data in order to get the final velocity squared in order to plot it. Now, when we go to Desmos to plot this, this is what it's going to look like. So again, in the x-axis, that's our h initial data. So this is the h initial, the 2.5, 3.5, and so on. And then the y-axis, that is the final velocity squared data. Again, the 40, 67, and so on. Again, not final velocity squared. And from here, this number here, m, is going to give us our experimental value for the slope. Now, I want to know what g is going to be, the acceleration of gravity. Well, we know that the slope is going to give us our experimental value for 2g. So from the equation that we used and how we plotted it, the slope value equals 2g. Well, I know my slope value is 24.1, so I can just divide 2 to both sides. So I take that and I take my 24.1 value for m, I divide by 2, and I arrive at an experimental value of 12.05 meters per second squared for our g value. Now, this is a bunch of dummy data that I made. You're going to get your own data from the simulation that you're going to use, and you're going to calculate your own value for g as one of the questions we're going to be doing, okay? So 3 steps again. We're going to be acquiring data, and this is what the simulation looks like, and I'll walk you through that here after this. Now, I zoomed in here at the bottom because this tool is going to tell us what the speed is at the bottom here. And here the speed is 10.87 meters per second. Now, we're going to be plotting that value squared. So you got to take that, you got to square it in your calculator, and that's the number you're going to be putting into Desmos because, again, the y-axis is the final velocity squared, the height initial is our x, and then our experimental value for 2g is our slope. And then once you've done all that, there's a lot of questions I have for you in the lab assignment for this week. Let me walk you through how to do the simulation. All right, so when you go to the simulation link, you're going to arrive at this screen. We're going to do the measure one, so the second one. So we're going to click twice on it to open it up. Now there's 2 things that we're going to do. We're going to go over here to grid, click on grid, And then we're going to take the edges of this ramp and drag it all the way to the top left, and take this one and drag it all the way to the top right. Now we can pick up the skater and we can place her at different heights. The first height that we want to place her at is 7 meters. So if you look here, we have 2 meters, 3 meters, 4 meters, 5 meters, and so on. So there's a little red dot. We want that little red dot to be at the 7-meter line. Do you see how the little red dot's at the 7-meter line here? And then I can release her from rest. And then I can pause it, and I can take this tool and I can drag it over different data points. And it's going to allow me to record what the velocity is here at the bottom. So here we're not exactly at the bottom. That's okay. We just want to be really close. This is some uncertainty in our data. And our speed at the bottom is 11.68 meters per second. So we're going to take our calculator. We're going to type in 11.68 and we're going to square it. And we get 136.4. So we'll go over to the Desmos link that I'm going to give you. For 7 meters, we're going to plug in the 136.4 in for our first value. Now the next one is at 6 meters. So we're going to take her, we're going to drag her to the 6 meters. See the red dot's at 6 meters. And then we're going to play. Now, a lot of times, one of the dots that we can use to get data doesn't always land at the bottom. So let it run for a while until you get one of those dots that's at the very, very bottom, okay? So let's see if we can get one. Yep, that one's pretty close to the bottom. So this is the one that we're going to use for the 6-meter mark, okay? If you don't do that, then your data is going to be a little bit off. Like if you use this point or this point, your data is going to be a little bit off. So be sure to wait until one of the data points is very close to the bottom, okay? So once you do that for all of these, all the way down to 2 meters, you're going to look at your slope and your y-intercept, and then go ahead and answer the questions in the lab for this module, okay? All right, let's get to it.